Given f of x equals 1 over x plus 5 minus 3, sketch f of x, f inverse of x, and solve f of x equals f inverse of x. So let's have a look at these sketches first of all. If we start with x getting mapped onto x plus 5, we know that that's going to give us a graph that has gradient 1 going through 5. So that's y equals x plus 5, that's 5, and that will be negative 5. When we take the reciprocal of that, we know that dividing by 0 generates an asymptote, so that will be at negative 5, because here is 0, so we get our asymptote there. And the reciprocal graph is going to look something like that. Okay, if we then go to 1 over x plus 5 take away 3, then the graph gets shifted down 3, so we can put our axes on, we can put our asymptote on at negative 5, and the graph gets shifted down 3, so the x-axis, which was an asymptote, gets moved down 3, so here we've got negative 3. So our graph is going to look something like that. Okay, sketch f inverse of x. Well, if we add that onto the same graph, so let's switch colours. If we reflect, we know that if we're getting the inverse, we need to reflect in the line y equals x. So the asymptote that was at minus 3 is now going to be a vertical one at x equals negative 3, and we're going to have a horizontal one at y equals negative 5. So now the graph is going to have this kind of shape, and here it's going to have that shape. Okay, and if I'd drawn it carefully, the points where they cross, because it's been reflected in the line y equals x, must be on that line. So when we come to solve f of x, so solve f of x equals f inverse of x, any point on the line y equals x hasn't moved because that was the line we were reflecting it in. So we can actually solve f of x equals x, which gives us 1 over x plus 5 minus 3 is equal to x. So we could go 1 over x plus 5 is equal to x plus 3. Expand, 1 equals x plus 3 times x plus 5. So 0 equals x squared plus 5 8x plus 14. And you could tap that in the calculator to get your values for x, or we could just quickly complete the square. So we get x plus 4 squared minus 4 squared plus 14. So we get x plus 4 squared minus 2. So 2 rooted plus or minus 4 equals x as the points of intersection. two possible solutions. Both of them look like they're negative on the sketch, which fits with what I've got here. Okay,